All right, everyone, today we're going to take a look at plotting versus sketching quadratics, and we're going to be using our TI Inspire to help us do this. So we can see here, I've got a window in my worksheet here, and I'm just taking a look at the window here from -3 to 7, from -10 to 15, more or less. And just for reference on my TI Inspire, right, if I double click on text, okay, on these sort of endpoints for my axes, you can go ahead and change those endpoints. So if you wanted that to be -4 instead of -3, you can easily kind of change your window like that. All right, so I've got the same window up on my TI Inspire and on my worksheet, so I can go ahead and get started. The nice thing about my TI Inspire is once I have graphed a function, notice, so here I have f1. So f1 is the function x squared minus 4x minus 5. So when I come over to, say, a graphing page, if I open up a graphing page, every time I input f1, okay, it is going to pull up that function, okay, that I had saved previously, okay. Okay, so I can quickly and easily go ahead and calculate all these values. That's how I have all of these values here, and I've filled out this table previously. Okay, so I have that graphed. I've got all those points plotted out. And we want to take a look at the difference between doing that and just getting a quick sketch of our curve. Okay, so some of the key points that we're going to need to show are going to be, say, the maximum or minimum in this case, our zeros or our roots or our x-axis intercepts, which we can see here look like they are at -1 and +5. Okay, but we can go ahead and sort of verify that, as well as our our y-axis intercept there and there. Okay, so if I have those points, I should be able to get a pretty good sketch of this curve here. Okay, so the first one, and we're going to do this using standard form, factorized form, and our vertex form, so sort of all these forms that we've seen in the past. So to go ahead and do this, first thing I can do is find my y-axis intercept, because when I have my quadratic in standard form, right, my y-axis intercept is going to be what my output is when my x is 0, right? So I'm asked to find what is f of 0. Well, when f of 0, if I look at this in standard form, here this x squared term is going to become 0. This 4x will become 0 because that's 0 squared minus 4 times 0, which is just 0. Okay, so that's going to give me an output of -5, which is what we saw here on my graph. All right, so I can come down here and I can roughly plot the point 0, -5. Okay, next thing I'm going to need to do is go ahead and factor this out. Okay, x squared minus 4x minus 5. So in order to put this into factored form, we can go ahead and do our crossroads method. So I need to think, what is a number that multiplies to -5 but adds to -4? So what are two numbers that multiply to -5, add to -4? And that is going to be what? -5 and +1. Okay, so -5 and +1. Okay, so that would be, for factorized form then, I would have x minus 5. Okay, that takes care of my -5 here, and then x plus 1. Okay, so how does that help us? Well, for our factorized form, I know if I set each of these factors, x minus 5 and x plus 1, if I set individually each of those equal to 0, so I'll do this off to the side here, x minus 5 equals 0. If I solve this for x, I get x equals 5. Okay, and independently, I can set x plus 1 equal to 0, and if I solve that for x, I get x equals -1. All right, so I can then go ahead and sketch this point here, -1, 0, and then I can roughly sketch again the point 5, 0. Okay, so that would be one of my zeros there at 5, 0. This is going to be -5, 0, -5, and this would be -1, 0. Okay, so the only thing that's left is going to be this minimum point in this case, or in other words, our vertex, and we can do this by finding the vertex form. So what we need to do here is we need to go ahead and complete the square of our x squared plus or minus 4x minus 5. So first thing we do when we complete the square is I'm going to make sure I'm going to sort of move this negative 5 way over here because I don't need that just yet. Okay, I take a look at my negative 4, and remember I do two things. I take my negative 4, I divide by 2, which gives me negative 2, and then I go ahead and I square that, which gives me positive 4. Okay, so that is the number that I'm going to put back up into here to complete the square. Okay, so that was a positive 4, so I'm going to add 4 there. Now, because I added 4, I've effectively changed my function. So to undo that, on the outside here, I'm going to minus 4. Okay? So to go ahead and complete the square, I need to take a look at sort of what I have in parentheses here. I'm going to use my crossroads method and think what multiplies to positive 4 and adds to negative 4. Okay, well that's going to be negative 2 and negative 2. Okay, so I come over here and then I'll say x minus 2 whole squared. Okay, so that is what, if I expand this out, x minus 2, that would be x squared minus 2x, so minus 4x. And negative 2 times negative 2 would be positive 4, so I would get exactly what I have up here in my parentheses. Okay, and then I have minus 5 and minus 4, so that would be minus 9 at the end there. Okay, so my function here is, it's the same function, right? All I'm doing is I'm representing it in a bit of a different way. Okay, so my vertex form is going to be x minus 2 quantity squared minus 9. Okay, and notice down here, what is my my vertex? Well, my vertex is at 2 minus 9. Okay, we can kind of see that both on the table up here, as well as down here on my graph. Okay, so our vertex form, just a reminder, looks like x minus h whole squared plus k, where my vertex is the coordinates from both h and k. So h comma k are the coordinates of my vertex, which I can find from the equation when my function is in vertex form. Okay, so there we go. I can come over here and I can roughly sketch 2, negative 9, 2, negative 9, and there we go. We've sort of gotten the important points there. So we got a quick sketch of our curve versus the sort of more detailed graph, okay? And we are using multiple forms of our quadratic in order to get these sort of important points figured out.